Hey everyone, and welcome. We're about to pull back the curtain on one of the most vital, yet almost completely invisible technologies that powers our entire world. The hidden network of wires and cables that connects, well, everything.
Seriously, think about it for just a second. From the light switch on your wall to the internet backbone that spans the entire globe, what is that one common thread? It's not just about electricity or data, but how that stuff actually gets where it needs to go.
The answer is this incredible hidden matrix. But you got to forget any idea of a simple copper strand. Every single one of these cables is a unique piece of purpose-built engineering, designed for a very specific job in a very specific environment.
So, to really wrap our heads around this matrix, let's start somewhere we all know, right inside the walls of our own homes. These are the cables we rely on every single day, even if we never ever see them.
You know, even in this familiar space, the specialization is just amazing. The wire inside your walls, it's got to be flexible, sure, but way more importantly, it's fire retardant. And that is an absolutely crucial safety feature. But the big cable that brings power from the street to your building, that's a whole different animal. It uses something called XLPE insulation, which is just a fancy way of saying it's super heavy duty and can handle a lot more heat. Then you've got the bundled lines hanging over the street. They're insulated to make things safer and even to help reduce power theft. So you see, 3 totally different jobs, all needing their own highly specialized designs.
All right, let's switch gears. We've talked about brute force power. Now let's get into the intelligent stuff, the signals. This is where the real magic of modern technology lives. And believe me, it requires a completely different class of cable.
And this analogy is just perfect. Power cables are the arteries, right? They're just pumping that electrical lifeblood everywhere. But data and control cables? They're the nervous system, carrying all the precise, sensitive commands that make everything smart, from a factory robot all the way to your internet connection.
Now, the biggest enemy of this nervous system is something called electromagnetic interference, or EMI. You can think of it as electrical static or noise that gets generated by big power lines and motors. For a huge power cable, it's no big deal, but for a delicate little data signal, this noise can be an absolute disaster.
So how do you protect those precious signals? Well, with cables like this. Instrumentation cables are the true unsung heroes of industry. They are literally wrapped in shields of aluminum foil or woven copper braiding that act like armor, blocking out all that EMI and making sure the signals from critical sensors get through loud and clear.
So how do we move just massive amounts of data? A standard Cat6 network cable sends data as electrical pulses down a copper wire. It works, for sure, but it's still vulnerable to that EMI noise we talked about. A fiber optic cable, though, sends data as pulses of light through pure glass. I mean, think about that. It uses light, not electricity. This makes it completely immune to all electrical interference and gives it just massive bandwidth. It is, quite literally, the superhighway of the internet.
Okay, so we've seen the cables in our homes and offices. Now it's time to zoom out, way out. We're now looking at the colossal arteries of the national power grid, the things designed to move immense amounts of energy across hundreds and hundreds of miles.
Power's journey is all about efficiency. It starts at a low voltage for our neighborhoods, then it gets stepped up to a medium voltage to cross a city, and then it's boosted to extremely high voltages to be sent cross-country. And the reason is actually really simple. Higher voltage means less energy gets lost as heat along the way.
And those seemingly simple wires you see hanging from those giant towers, they are total engineering marvels. The most common one is ACSR. That's short for aluminum conductor, steel reinforced. The steel core gives it the raw strength to span those huge distances. But what if you're near the coast? The salt in the air would corrode that steel. So they use AAAC, an all-aluminum alloy conductor that resists rust. And in forested areas, they use covered conductors. They have just a thin insulating layer, but it's enough to prevent a blackout if a tree branch happens to touch the line. Every little detail is a solution to a problem.
And now, for the grand finale. Let's look at cables that are built to survive conditions that would destroy anything ordinary. These are the special forces of the cable world.
A solar panel has to last for over 25 years, just baking in the sun, getting hit by rain, ice, and extreme heat. Well, the cable connecting it has to do the exact same thing for the exact same amount of time without cracking, degrading, or failing. That requires some seriously advanced material science.
Now just try to imagine the inside of your car's engine bay.
It is a nightmare environment. We're talking constant vibration, intense heat, and exposure to nasty stuff like oil and gasoline. Automotive cables have to be tough enough to handle all of that, while also being flexible enough to be routed through these incredibly tight spaces.
So what is the absolute most extreme environment you can think of? To survive it, a cable would need to be pretty much perfect, exceptionally lightweight, totally fire-resistant, and chemically inert.
We're talking, of course, about aerospace cables. In aircraft and spacecraft, every single gram costs fuel, so these cables are engineered to be astonishingly lightweight, using advanced materials like PTFE, which you might know as Teflon. It's not only light, but it's also incredibly resistant to heat and chemicals. They are, hands down, the most robust and precisely engineered cables on or off the planet.
And that really brings us to the key takeaway here. The next time you plug something in or see a transmission tower, just remember that you're looking at one tiny piece of a vast hidden network. And each wire is a solution to a specific problem, a piece of precision engineering that's hiding in plain sight.
It really makes you wonder, doesn't it? As we keep pushing into new frontiers with things like hyper-efficient smart grids and quantum computing, what kind of incredible new cables will we need to invent to solve that next generation of problems? Thanks for joining us for this explainer. We'll see you next time.